ionization potential. All of you, your notebook, factors affecting the ionization potential. All of you write down your notebook, factors affecting the ionization potential. So first factor you write down atomic size. The first factor you write atomic size. Now what is the relation between atomic size and ionization potential? So ionization potential is inversely proportional to atomic size. Both are what? Inversely proportional. That means atomic size increases, ionization potential will decreases here. For example, in the group, okay, top to bottom, in group, top to bottom, atomic size will increases or decreases better? Top to bottom, atomic size will increases or decreases? I or
Increases.
I or decrease? Some are taking decrease or increase?
Increases.
Some are taking some are saying what decreasing. How it decreases? Increases. Now tell me, ionization potential will what? What happen? Ionization in group, top to bottom?
Decreases.
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 Correct or not? That means if you know that everyone knows the atomic size, almost all 90% know, remaining 10% they don't know. Even they don't know what is atom also they don't. I know that one. Some of you what happened? 10% they don't attend to the class, they don't listen to the class. They know, I know that one. They don't know even atom also, but they know what football. But they don't know what is the shape of the atom. But they know football. They know cricket ball. The size, shape of the football they know, shape of the cricket ball they know actually, but they don't know what is atomic size, isn't it? Because they are interested in sports, not in, isn't it? Education. Leave it this one. So if you know atomic size, we can write ionization potential. If you know this relation, what happened? You can easily write here. Okay. So if I take one example for this one, lithium, which group? Lithium, sodium, potassium, rubidium, cesium. Tell me better. First A group or first A group. Lithium to cesium, ionization potential. Tell me better, ionization potential.
Decrease.
Now among lithium and cesium, which is having what? Lower ionization potential. Lithium and cesium, lower ionization potential. Cesium, very low ionization potential. Correct? Next. Let me take in period. Lithium to what? Lithium. Next what happened? Beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Now here it is period. Which period is second period? It is second period, right? Now lithium to what? Neon. Tell me ionization potential. Now
Decreases.
before the ionization potential, let me see first of all atomic size. Atomic size, what happened, beta? Atomic size
Decreases.
decreases. If atomic size decreases, ionization potential always what happen? Increases. Lithium, which is having more ionization potential? Lithium and neon?
Neon.
Neon is having ionization potential. I'm saying here in periodic table, then left side will have lower ionization potentials, right side, that means entire the right side will have high ionization potential. But in top side, if you observe, top ionization potentials will be more, and bottom what happen, ionization potential will decreases. So based on that, if we cumulatively if you observe what happened, which element is having very low ionization potential? What happened cumulatively, groups and period if you observe, that means left to right increasing, top to bottom decreasing. Okay. Now which element is having very low ionization potential?
Neon.
Neon. Rubidium. Except correct answer you are saying
Cesium.
top to bottom decreasing, right? Left to right increasing. Now tell me which is having lowest ionization potential in entire the periodic?
Cesium.
थोड़ा रखकर बोलो बेटा.
सर cesium.
कुछ बताओ। Yes?
सर सीजियम तो बोल रहा हूँ।
सर
सीजियम,
cesium.
सीएस बोलो, नहीं तो सीएस बोलो, कंप्यूटर साइंस बोलो, है ना?
सर सीजियम
Cesium, cesium, which is very important one. Which element is having very low ionization potential? It is called cesium. Very good, isn't it? Very low ionization potential is having what element is there after cesium? Francium is there, but francium is a radioactive element. Therefore, no need to consider that. Okay. Now, this is the thing you need to remember all of it. Remember this thing actually. Okay. This is very, very important.
Sir, in exam, which should we write, cesium or francium, sir?
Cesium only you need to write because francium is half-life period is only 21 minutes. Only 21 minutes. So it is highly unstable. So whichever is highly unstable, what critically francium only. Critically, if you say what happened, francium. Experimentally, what happened? Which one is correct? Cesium only. Okay. Given cesium and francium, what happened? In question, they will clearly they will mention that whether theoretically or practically what. Okay. So no problem in that case. Okay. Generally, we say cesium only. We don't take francium because it's not available. No. So why would you say what happened francium? So definitely the answer must be cesium only. Okay. Leave it this way. Next. Second factor after atomic size. Second factor, if we see nuclear charge. Now, nuclear charge directly proportional to ionization energy. What is the reason? If you observe, when you have nuclear charge is more, nuclear force of attractions also will be more. Understood? When nuclear force of attractions are more, what happen? We have to supply more amount of energy to overcome what happen? Nuclear force of attraction. So, higher the nuclear forces, what happen? Higher energy we have to supply to remove the electron. So in that case, what happened? Nuclear charge is directly proportional to what? Ionization potential. Second order. In first order, inversely proportional. In second order, directly. Understood the concept? More nuclear charge, what happened? More energy is required to remove the electron. Isn't it? For example, class is going on. There are something what 30 students are there. There are what happened in this class, what happened? 5 teachers are there, or 10 teachers are there in the class. Is it possible to escape from the class? Is it possible? No,
No,
no.
sir.
Similarly, what happened when nuclear charge is very increasing, what happened? They attract electrons strongly in that case. When they attract electrons strongly, what happened? Removing the electron is very difficult. That is the reason this is the order, directly proportional, right? Next, third one. Third one, the definition I already told you. Anybody? What is the definition of screening effect? Anybody is possible? What is the definition? Yesterday, I think we completed the screening effect, I think. Anybody? What is the definition of screening effect? Had your lunch, everyone? Had your lunch, everyone?
No, sir.
No, sir.
No, sir.
At what time your
No,
class
sir.
daily? At what time your class is starting daily? What time you are
So
having class?
today 12 o'clock.
No, generally before 10 o'clock.
11 o'clock, sir.
Okay. Now I do one thing. In 1 o'clock, what happened? I think you are also getting hungry, and most of them you are what happened not listening. So I shall I take before what happened around 9 to 10 o'clock. If I take daily 9 to 10, I will take.
Yes,
Okay,
sir.
sir.
Okay.
Fine,
Yes, sir.
Yes,
Yes.
sir.
Fine. No. 9 to 10. Fine. I don't
Yes,
take.
sir.
Yes, yes.
Hours, what happened? You join by 9 o'clock. Just 10 up to 10 only. Sharply 10 o'clock. I will leave you. But daily I will take the class so that we
Okay, sir.
in detail we can discuss. Okay. Tomorrow onwards, you directly join at 9 o'clock. Right. Right. Now, no problem. Let's see the screening effect. Screening effect means, again, I will repeat, there will be outermost electrons will be there. For example, if I take the nucleus here, this one I have taken actually a nucleus. Just a minute. This is a nucleus I have taken. Now this is the first shell, second shell, third shell like this. Now some valency mostly loosely electrons are present here. Some valence electrons are present here. Okay. Now some inner electrons also present here. Inner electrons also there. In the first shell, second shell, some inner electrons are there. Now this nucleus now here, if you observe this nucleus, unable to attract these electrons. Unable to attract the electrons. Even the nucleus is there, what happened? Because of the inner electrons, no. They are unable to attract outermost electron. What is the reason? Because the inner electrons are shielding or screening outermost electrons. Isn't it? Some screen is there. Just imagine some screen is there. The screen is made upon by whom? Electrons. A screen is made upon by whom actually? Electrons. And this screen is preventing what? Attracting of outermost electrons by the nucleus. This is called what actually? Screening effect. Understood everyone? Everyone understood screening effect? If you have any doubt, again ask me.
Yes, sir.
No doubt? Not doubt your hand. Shall I proceed?
Yes, sir.
Yes, sir.
Now observe, because of the screening effect, because of the formation of electrons like a screen like this here, what happened? This nucleus unable to attract what happened? Outermost electrons like this. Now we can remove these electrons very easily because they are not strongly attracted by the nucleus. Now tell me, screening effect is inversely proportional or directly proportional to ionization potential?
Sir, inversely.
Direct.
Inversely
Sir,
proportional.
inversely.
More screening effect. More screen is there. More screen is there like this. More inner electrons are
Yes,
there.
sir. Inversely.
More inner electrons are there. More screen will be there. In that case, what happens? We can remove electron very easily. So it will be inversely proportional. बयान नहीं करना बेटा, आपको बयान नहीं करना ऐसा इन्वर्सली प्रोपोर्शनल डायरेक्टली प्रोपोर्शनल ऐसा बयान नहीं करना है, आपको इमेजिन करना है स्क्रीन कैसा आएगा आपको इनर इलेक्ट्रॉन से आएगा. When you get more number of inner electrons, they can screen the outermost electrons. Okay, so this is a thing you can remember actually, right? Screen third effect is completed. Next, let me take penetrating effect. Now, what is the meaning of penetrating effect? Now, the tendency of orbital to move towards the nucleus is called penetrating effect. The tendency of orbitals to move towards nucleus means, I will explain by just taking one diagram actually. Okay, let me take some diagram actually. Now, so if I write something, what happened? The nucleus. Okay, now first orbit, second orbit, third orbit, and the fourth orbit. Better. This is the fourth orbit. This one is the fourth. So now fourth orbit will have s orbital, p orbital, sorry, here I am writing. The fourth orbit is having p orbital, d orbital, and f orbital like this. F orbital, right? Now, if you see this one, which orbital is near to the nucleus? Tell me. If you see this one, which orbital is near?
S.
S is near, right? Very good. S is near. Compared to this, P is what? Away. D is more away, and F is what? Far away from the nucleus. So that is the reason what happened. S is more penetrating when you compare with P and D and F. So removing electron from the S orbital is difficult or F orbital is difficult? Tell me better. Removing electron from the
S orbital.
S is difficult because the electrons which are present in the S orbital are what? Very much near to this nucleus. So that is the reason penetrating power directly proportional. So which is having more penetrating effect? S is having more penetrating effect. For example, I am writing electrons are like 4s2, 4d2, 4p2. यहाँ पर 4p2 भी लिखो. Next 4f2. Now which electron we can easily remove beta? 4s2, 4p2, 4d2 or 4f2. Which electron we can easily remove?
4F.
4f2 we can easily remove. whereas 4s2 is very difficult to remove. Okay, now we get a small doubt actually. We get a small doubt. I will explain that one. Shall I take water? Zinc and take. I'm taking here what? Zinc. Okay. Now zinc configuration 1s2, 2s2, 2p6, 3s2, 3p6. Next what happened? 3d10, 4s2. This is the configuration, no? Now in 4, only one s orbital is there, so there is no p and d and f here. So obviously we can remove this electron is very easily. But among these, which electron can be easily removable? Among these, s orbital, p orbital, d orbital?
E.
This
D.
one, 3d10. That means when you remove electron, this value, the n value must be same. So you have to choose from n value. You can't just say 3d10, 4s2. If I say, sir, 4s, it is very simple. No, that is not correct. If I say something, what happened? That is not correct. You have to see the n value also here. The value of n must be same here. Now value is not same here. So in that case, what happened? Whichever is having more n value, that can be easily removable. Understood my point here? Okay, you can't take like this 3s, 4d, 3p, 4, 5p, like that you can't select here. The n values must be same. In this case, n value must be same here. That is a key factor for us. Must be same. Understood here? So ionization energy is what happened? Directly proportional to penetrating effect. Next, last one, electronic configuration. Whenever if we get half fill configuration, you have to follow all the rules. All the rules will be what actually violated. Okay, you can't follow any type of. You have to follow what? Half fill configuration or completely filled configuration. So whenever if we get half fill configuration or completely filled configuration, don't follow rules here. Follow what rule? Electronic configuration. So in which you are getting half fill and full fill configuration, they are having high ionization energy. For example, I will take nitrogen. You take what? Nitrogen. Just a minute. You take a nitrogen. So I am writing the nitrogen here and oxygen here. All of you, what happened? Note down this one also. Better to note down this one. Shall I write what happened? Last configuration. Last configuration means from 2s to 2p. Correct or not? 2p3. Is my voice is not reaching in time?
Yes, there, sir.
It takes some time. Otherwise, in time it is spontaneously. It is my voice is getting you.
Sir, in between the voice is breaking.
Voice is breaking.
Yes, sir.
No, sir.
No, I think voice breaks only when you get something what weak internet connection. So tomorrow, I think what happened, you morning onwards, you are using the mobile. That is the reason maybe your signal strength, maybe what happened, maybe weak. Otherwise, in afternoon, what happened, most of that signal will weak actually. Tomorrow onwards, I'll take morning, no, 9 to 10, no problem. Now I'm writing what 2p3 here. Now my voice and whatever I'm writing is synchronized or not?
Yes, sir.
Yes.
Yes, sir.
No. 2p3 I'm writing here, see. Like this. This is chor do 2s ko chor do because both are 2s to leave it that one. Now 2p4 in this way outright. Now tell me which is having half fill configuration here?
N.
Nitrogen is having half fill configuration. It is stable. Having half fill configuration is stable. Correct or not? Now this is not having column on this is not you can't say what happened unstable, but it is less stable when you compare with what happened half fill. I'm writing what less stable I'm writing. Now according to the rule is what actually nitrogen, oxygen. Which period actually they belongs to? Second period. Second period left to right. Ionization atomic size what happened? Decreases. Ionization potentials actually should what happen? Increases.
Increase.
According to the rule, ionization potential should increase. Correct or not? Tell me.
Yes, sir.
Yes. Now, based on this, nitrogen should have less ionization energy than oxygen based on what happened? Atomic size. This is based on what happened? Atomic size. At atomic size, what happened? Decreasing. Ionization energy, what happened? Increases. Correct? But whenever if you get half filled configuration or completely filled configuration, you have to neglect the rule actually. So now, because of stable half filled configuration, nitrogen is having what? More ionization energy. Correct? So this is the fifth one, electronic configuration. With this, what happened? I have completed, isn't it? All factors affecting. What factors we have completed? Anybody? First factor is what? Atomic size. Second factor is what? The second
Nuclear charge.
Nuclear charge.
nuclear charge. Third factor is what?
Screening effect.
Screening
Screening
effect.
effect.
Fourth factor is
Penetrating effect.
radiation power. Fifth one is what? Finally, we discussed
Electronic configuration.
configuration. Okay. Now, one note, if you observe what happened, in any period, if you observe, in any period, either first period or second period, group 18 elements are having maximum ionization energy. Now, for example, in third period, which element is having highest ionization energy in the third period? Which element is having highest ionization energy? You have to go for group 18. Go for what? Group 18. Third period element. Which one it is?
Argon.
Neon.
Yes, argon. Neon is second period. Helium, neon, argon, krypton, xenon, radon, oganescent. These are two are radioactive elements. Leave it this one. Okay. Now, in third period, argon is having highest ionization enthalpy. Now, which element in the entire periodic table? In entire periodic table, which element is having highest ionization potential? Which element is having highest ionization potential? Highest two.
Helium.
Because left to
Neon.
right increasing, top to bottom decreasing. Therefore, helium is having highest ionization potential, where cesium is having lowest ionization potential. Now let me see this one. 1 to 60 elements are there. How they are varying? If you observe here, what happened? Helium, lithium, isn't it? How it is varying? See, in this way it is varying. तो observe करो यहाँ पर in any period. So for example, this is the first, here is the first period. Just imagine second period, third period, fourth period, something what happened, fifth period, sixth period, sixth and seventh is leave it because they're what happened. I told you, no, they're radioactive elements. They're very highly unstable, so they don't available. Leave it that. Now you observe in first period, helium is highest. In second period, neon is highest. In third period, argon is highest. In fourth period, krypton is highest. In fifth period, xenon is highest. So what I'm observing here, in any period, group 18 elements are getting highest ionization potential, and lowest you are getting from which group element you observe? First A group element. In all the cases, in first, second period, in third period, fourth period, fifth period, sixth period, isn't it? If sixth period, fifth period, fourth period, third period, second period, first period. First A group elements are having lowest ionization energy. So what I mean to say is that, so first A group elements are having lowest ionization enthalpy, whereas group 18 is having highest ionization enthalpy. I want in fourth period. I want in the fifth, something what fourth period. In fourth period, which element is having lowest ionization potential beta? In fourth period, which element is having lowest ionization potential? In fourth period,
Potassium.
potassium. Which is having highest one in fourth period?
Argon.
Krypton. That is argon is third period, no?
Sir,
Yes,
Kia.
yes.
Neon is second period, argon is third period, krypton is what? Fourth period. So in fourth period, lowest is potassium, highest is
Potassium.
so this is remember. You remember this point. Which one? This one. First A lowest, group A then highest. Useful for you. Very much useful for you. Tell me the answer for
Potassium, sir.
Sir, A cesium.
नो देखो बेटा ऐसा क्वेश्चंस आपको देने दिए तो आपको ये करना है इसको अरेंज करना है ऑल आर व्हाट फर्स्ट ग्रुप एलिमेंट लिथियम सोडियम पोटेशियम सीजियम नजर फर्स्ट ए ग्रुप एलिमेंट्स तो टॉप टू बॉटम decreases which one ionization potential so least will be what actually which is having least one
Cesium.
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 तो देखकर आपको बताना नहीं आपको लिखकर बताना है लिखकर ऐसा ड्रा करके बताना है ठीक है ना element is having highest one now tell me all are what same group elements
Helium.
helium is the highest whichever it is the correct order
Cesium.
which of the following is correct order do they belong to same group yes now then top to bottom
Option B.
sodium
Sir, B, sir.
Helium,
helium
sir.
cesium so ionization potential is what happened decreases sorry decreases there what decreases
Sir, helium.
decreases helium कहाँ है यहाँ पर ना कहाँ पर है ऑर्डर सोडियम पोटेशियम रुबिडियम सीजियम सोडियम ओके पोटेशियम रुबिडियम बी इज द ऑप्शन right now here the question arises here which of the following element has highest ionization enthalpy now in this case what we have to follow here because there is no group here all are what different groups in that case what we have to do here now you observe here what happened all are having what how many electrons 10 only observe correct or not tell me first of all are having electronic carbon correct or not beta
Yes, sir.
so electronic or not right now for isoelectronic order what is size atomic size
Sir, 2 times there is energy, sir. Plus
z
2.
by is inversely proportional to what here atomic size correct or not higher the z by e lower the atomic size correct or not beta which where we have discussed this one in the I think last classes we discussed this topic are correct or not z by e ratio पता है ना आइसोइलेक्ट्रॉनिक स्पीसीज में हमने पढ़ाई कंप्लीट किया ना
Sir, option D शायद wrong है. Option B, sir.
क्या
So option B. Sir, wrong है,
Option
sir.
B. हाँ कोई बात नहीं देखेंगे हम आंसर कोई कौन सा करेक्ट आंसर वी विल डिस्कस दैट फर्स्ट ऑफ ऑल दिस इज z by रेशियो इज इनवर्सली प्रोपोर्शनल टू एटॉमिक साइज तो मैं अब ऐसा लिखता हूं इसमें F माइनस सोडियम प्लस मैग्नीशियम प्लस एंड मैग्नीशियम प्लस 2 पहले इसमें z by लिखना है ना z by रेशियो लिखना है ना एटॉमिक नंबर सबका कितना है यहाँ पर 9 इसका कितना है 11 12 नाउ ई वैल्यू कितना है बेटा इसमें सभी में कितना है ई वैल्यू कितना हो जाएगा ई वैल्यू इसमें 10 only because they're isoelectronic when they're isoelectronic they will have same electron 10 now what is the value the value is what 1.1 1.2 now here sorry this one I am 12 okay right
11, sir. 12 by 11.
just a minute magnesium plus 1 no just a minute beta this is not sorry just a minute okay this is not isoelectronic no this is not isoelectron this has what 11 electrons right
Yes, sir.
this is having 11 electrons so I put actually here 11 right so 12 by 11 will get something 1 point less than 1.2 but more than 1.1 isn't it 12 by something 11 is equal to something 1.09 almost 1.1 but then something what happened you are going to get 1 point how much it is 09 12 by 11 is equal to 1.0 now write down the Z by ratio order. Now Z by ratio order will be here. F minus is having lesser than Z by ratio. I'm writing here. Z by ratio. Z by I'm writing. F minus is lesser than what? Magnesium plus. Then what? Na plus. Then what here? Magnesium plus 2. This is Z by ratio. Now Z by ratio is inversely proportional to what? Atomic size. So that is the reason what I am writing here. Atomic size. आपको क्या लिखना है? F minus is what? More size. Then compare with magnesium plus, Na plus, and magnesium plus. Next, atomic size is inversely proportional to ionization enthalpy. I am writing here ionization enthalpy. Now F minus is lesser than what? Magnesium plus, Na plus, and what? Mg. Now this will be the ionization enthalpy. Now what they are asking, which is the highest ionization enthalpy? Magnesium plus 2 is the highest ionization enthalpy. तो मैं ऐसा लिखूं आपके लिए Z by ratio is directly proportional to ionization potential. Is it correct or not? Tell me better.
Yes, sir. Yes, sir.
Yes, sir.
In this way we can easily identify. यहाँ पर आपको लिखने की जरूरत नहीं है, एक्चुअली ज्यादा लिखना है ऐसा, इस पे सोचने के लिए कुछ नहीं, इस पे नंबर आपको आइडेंटिफाई करना है 0.9 1.9 1. आइडेंटिफाई करने के बाद ये आपको याद करे तो आएगा इसमें. यस, नेक्स्ट. Now this already you know this one. Which option is correct one?
P.
C option is correct. This one is correct. S is greater than P, P is greater than D, D is greater than F. Now tell me the answer for this one. Is it possible? Ionization order of nitrogen, oxygen, fluorine, neon.
D, sir. Sir, B.
All are in same period. All are in same
B,
period.
sir.
Left to right, what happened? In period, ionization energy, what happened? Always increases. So definitely what happened? Neon. Then what happened? Nitrogen. But because of why you are getting a contradiction here? Because of half filled configuration. This is having completely filled configuration. Completely filled. This is having what? Half filled configuration. Okay. After that we get fluorine. No, where is fluorine? Oxygen, neon, nitrogen. So next, second option is the correct one. This one is neon, fluorine. This one is correct. Completely filled. Otherwise, what happened? Last one. Okay, last one. Generally, what happened? Nitrogen, oxygen, fluorine, neon. Correct. Left to right, what happened? Ionization potentials, what happened here? Increases. Now, which is having most one? Neon. Least one should have nitrogen. But among these two, we'll take what? Oxygen is lesser than nitrogen because of what? Half filled configuration. Because of half filled configuration. Fluorine as usual. Fluorine का कोई आपको चेंज नहीं करना है, आपको रूल आपको फॉलो करना है. मगर नाइट्रोजन ऑक्सीजन में कौन सा रूल आपको फॉलो करना है? हाफ फिल कॉन्फिगरेशन. सो आंसर विल बी व्हाट? नियॉन ग्रेटर देन फ्लोरीन, फ्लोरीन इज ग्रेटर देन नाइट्रोजन, नाइट्रोजन ग्रेटर देन ऑक्सीजन. सो सी विल बी द करेक्ट ऑप्शन. करेक्ट, राइट? ये दिस टाइप ऑफ क्वेश्चंस इंपॉर्टेंट. This type of questions make you some confusion here. Okay, so confusion is not there for neon. So this is the rule we have to follow. Left to right, what happened? Ionization potential will increases. Only in the case of what happened, that means 15th group and 16th group, you are getting this type of contradiction. Okay, what I'm saying, 15th to 16th group elements in same period, isn't it? In same period, this ये आपको notebook में लिखो बेटा है. Same period, in same period, group 15 to group 16, ionization enthalpy is what happened? Decreasing. After that, again what happened? To 17 and 18, it will again increase only. This is a where only we get the some contradiction, isn't it? Because of half fill configuration, right? Group elements will have highest to ionization energy beta.
E.
In the group, 16th group, 17th group, 18th group. So answer will be what? D only, right? But trends, if you observe what happened, this is already I explained here. Ionization energy in period, what happened? Left to right, increases. Reason? Atomic size decreases. In group, ionization energy, what happened? decreases top to bottom. मैं already आपको explain किया. In alkali metals have lowest ionization energy. सारी हमने bit किया. Reason the atomic size increases with effective nuclear. Already मैं increase किया, explain किया. Now देखो यहां पर आपको जनरली देखो बेटा एक बार ये देखो फर्स्ट पीरियड है ना बेटा, दिस इज फर्स्ट पीरियड और सेकंड पीरियड. टेल मी हाइड्रोजन हीलियम.
The first.
No, I told you just now in period ionization potentials will increases. So from hydrogen you observe here what happened, having something 1300, having something 1300 kilojoules. Okay, helium is having how much here beta? Around roughly what happened, 1900 kilojoules. So left to right in first period. Okay, in first period left to right ionization potentials are increasing. So according to rule it is going, no problem for us. So if you remember the rule, no problem. A second period if you observe here, second period if you, this is the second period elements, correct or not? Yes, second period elements. Now in second period here also should increase. Yes, lithium is having around something what 500 kilojoules and neon is having around roughly what happened something what maybe something what 1600 kilojoules, roughly it is 600. Yes, it is also increasing, no problem. But where we are getting contradiction, tell me what happened, where we are getting some exception cases we are getting, tell me better.
Beryllium, boron,
Observe here what happened, increasing, increasing. Here also what happened, increasing, no problem. But in the case of boron suddenly decreased, in the case of oxygen suddenly decreased. Already we know this one. What is the reason behind this one, nitrogen to oxygen beta?
Electron.
Half-fill configuration.
Half-fill.
Because of half-fill configuration, suddenly what is happening, nitrogen to oxygen, because of half-fill, which is having half-fill configuration, this is having half-fill configuration. Because of half-fill configuration of nitrogen, suddenly nitrogen to oxygen, the values are what happen here, decreased. Now what about the beryllium to boron if you observe here? Now I am writing the beryllium configuration here, beryllium configuration. So helium configuration will be better 2s2, correct or not? 2s2 is what, completely filled or not? Yes,
sir.
Boron, anybody? Boron configuration? Yes, आवाज भी नहीं है आपका.
2s to 2p1.
2s to 2p1. Now where you are getting single electron, where we can remove as an electron very easily, in case of single, if you have single electron you can remove easily that electron. Here that is paired electron, it is what, paired electron, completely filled electron, paired electron, correct or not? Now in which case the ionization energy is less, beryllium or boron?
Boron.
Boron.
Actually, according to the rule, beryllium to boron ionization energy left to right should increase. But in true observation, beryllium is having what happened, greater than what happened, boron. The reason because behind this one is what, 2p1 configuration. The boron is having 2p1 configuration. So you are getting what, isn't it? Two exception cases here. What are the exception cases? I'm writing again here for you, for your understanding. I'm just removing these values, everything. So simply to show here, two exception cases. Where are they? In first period, you don't have any exception here. Left to right increases. In second period, also it will increases. Two exceptions are there. Here it is just two exceptions, because it is having 2p1 configuration. Here you got a one more exception case. It is having what, 2p3. So remaining case is what, very simple for us. Okay. Now if you observe what happened, the third period. Now we'll take what, third period now. I'm just again removing this one also. In third period also you are observing same thing. You observe here what happened. Magnesium to aluminum, decreasing. And again, phosphor to sulfur, what happened? Decreasing. Not like second, but small decreasing is happening. Here also same configuration, half pill configuration, 3p3, half pill configuration. And in here also what happened? 3p1 configuration. 3p1, this one will be 3s2 configuration. So 3s2 removing is very difficult for us. So in both second period, what are the exception cases? Magnesium is greater than aluminum. In third period, sorry, this is third period, no, sorry. Second period, what happened here? Beryllium is greater than the boron. Next, one more thing. In again second period. In third period only. Phosphorus is greater than sulfur. In second period, nitrogen greater than oxygen. So these are the exceptions we are getting in this. Understood the if you understood the concept, what happened? You can n number of examples like this. In this way, we can write n number of things like this. N number of things we can write. Now already I told you this one. Okay, because of stable half pill configuration, nitrogen is more ionization enthalpy than what? Oxygen. In examination, they may ask this type of questions here. So try to remember this one. The simple thing, due to stable half pill configuration, right? What is the answer for this one?
Option A.
Increases, decreases?
A option.
Right.
Increases.
This one will be?
It decreases. Option B.
Decreases.
ऐसा practice करे तो याद हो जाएगा आपको. What is the reason here? In period, ionization energy increases due to increase in increasing in effective nuclear charge and decreasing in atomic size. A and B is the answer. It's already I told you, no need this one. This one also you can tell me, you can easily explain. Which one is correct one?
B.
Right.
B.
Okay. This is about what ionization energy is completed. We'll see what happened next topic. Okay, 5 minutes are there. I will complete this one within 5 minutes. Next topic, just I will give introduction only. We'll see that one also. Electron gain enthalpy. Just I will give definition. Remaining tomorrow I will discuss that. Electron gain enthalpy. So opposite to the ionization enthalpy, that is what actually called electron gain enthalpy. Opposite to what? Ionization energy is what? Electron gain enthalpy. So let me see what is electron gain enthalpy. Whenever electron is added, you see I have taken again isolated, I am writing here, isolated neutral gaseous atom. You see this is the isolated neutral gaseous atom. Now, having added with one electron, this is electron you are added with an electron. You are getting a mono-negative charge. You are getting a mono-negative ion. Now, in this case, the amount of energy exchanges, in this case, what happened? The amount of energy exchanges, that energy is called what? Electron gain enthalpy. So, simply I am saying the amount of energy exchanges when an electron is added to an isolated neutral gaseous atom is called what? Electron gain enthalpy. So, this is isolated neutral gaseous atom, this one. One electron you are adding. So amount of energy exchanging in this process is called what? Electron gain. Now in all cases, most of the cases what happen, when you remove electron, energy will be required, delta H will be positive endothermic. But when you add electron, delta H will be negative. When you add electron, delta H will be negative. Exothermic process, heat will be liberated. But not in all cases, most of the cases. I will explain exceptions where we get positive value. All the cases of ionization enthalpy, delta H is equal to positive. But in all the cases, electron gain enthalpy need not to be positive. It's something what happened negative, something what happened positive like that. So that we'll discuss in the next time. Okay. When delta H is negative, most of the cases, 90% what happens is a negative exothermic process. Now, when you add second electron, now you are adding some second electron, then that is called what? Second electron gain enthalpy or second electron affinity. So in that case, what happens? X minus will convert into X minus 2. Now in this case, positive. That means first electron gain enthalpy is always will be, always means most of the cases, 99% what happened, they are what actually negative. Except some cases are there, I will explain it later. But after that, second, third, fourth, whatever it may be, they're always what happened? Positive. So in this case, what happens, you know, so already this is having a negative charge. X minus is having a negative charge. Now you are adding one electron to this one. Now electron you are adding, already some excess of electrons are there here. So because of this, what happens? Repulsions will generate. Repulsions will generate. So when you overcome these repulsions, what happens? You have to some supply energy. You have to supply some energy. So this is about the definition actually, isn't it? So in tomorrow, what happened? Let me see this continuation of this topic actually. Okay, this takes some time actually. So tomorrow we'll continue this topic. Okay. At what time we'll take tomorrow class? 9 to 10 o'clock, right? Only 34 students are there now. Only 34. What happened? 15 members were absent today. थोड़ा एक एक्सरसाइज देखो बेटा, यहाँ पर एक्सरसाइज आपको ये सारी एक्सरसाइज आपको कर सकते हैं अभी। इसमें आपको 3.16 this part 3.16 3.17 3.18 3.19 okay. So you have to do this 3.16 to 3.19 as a homework, as assignment actually, okay. Complete this assignment by tomorrow.